an electronic enthusiast, and I've had a lot of experience on dealing with manufacturing defects for electronic components on the production line. And I thought I would consolidate some of the things that I've learned and post it on YouTube so that prospective employers and other enthusiasts could see what I know, and also to contribute to anything else that they want to add to what I've been communicating. So, I guess the basic summary is, what do you do when you have a component failure and you need to determine, is it an internal or external issue? Do I have bad raw parts? Is it my production processes that's damaging the component? Do I have a design issue? Do I have a tolerant stack up? Do I have a EOS or ESD defect that's due to some abnormality in, say, the humidity, or somebody or an operator has set the power supply voltage incorrectly and starting to fry some components. But you really don't know a readily source of where these defects are coming from. So, in a nutshell, what you need to do is break it down to, do you have an internal or do you have an external problem? And that is directly determined by looking at the suspect components themselves. And then that will help you guide you on how do you need to address this issue. And typically what would happen is I would get an informal email from one of the production line technicians saying that, okay, such and such a device is providing or is creating failure tickets. The product is not performing like it's supposed to, and when they replace it, okay, it fixes the problem and the assembly goes down the production line, and that's it. So what will happen is I'll interview the technician and try to figure out, well, how frequent have they been having these issues? Now, depending on your structure of your production line, usually what you have are run rules, where if you have, let's say, like 1 or 2 issues, a shift where, okay, you have a bad cap, that's not really anything you really need to worry about. But if your line techs are starting to replace 20 capacitors on a shift, you should have your quality department be alerted right away. Okay, after you've alerted the quality department, you need to think about doing material containment. And so what you do is you look at the samples that the blind tech has provided, find the date code, lot number, whatever have you from that particular component, and go from the production line wherever you have the materials on the production line, have that date code contained, and also make sure that you do the same thing for the warehouse. Later on, if you believe it is a external event, then you probably need to contact your vendor, and whatever control plan agreement that you have with the vendor is who you would contact. Usually you can get that information through your inside buyer. Now, once you have the material contained and you give them substitute different date codes or lot numbers that would allow the production line to continue, then you can investigate what's the problem with the component. And so again, interviewing with the line technician, and depending on the nature of the failure ticket, you can determine, okay, what's the characteristic that I need to determine that this component is defective. And usually what will happen is the line tech will replace the component, and they put it right back in the test fixture, and it passes. And so you'll have a handful of discarded defective components. Depending on discrete components, they're kind of reasonably robust against thermal shock up to a point. But what you could do is, like for example, if there are defective caps and they're on the low side of capacitance, or for example, another one is you have a circuit that's on standby and it needs to draw a very low current, and what happens, the component is leaky and it's drawing too much standby current. And so again, you know, they replace the component, and then you have these handful of scraps or suspect defect components. And so again, what you do is you look at the official agreement that you have between your company and the vendor on what's the characteristics that these components need to have. Again, what you'll have is you'll need to, I guess for the most part, look it up on Google, go to the vendor's website, and they'll have the characteristics, how to test the component. I'm going to use a capacitor, for example. And so like for example, they're saying that these caps are on the low side, and so you plug them into the LCR meter, you measure them per spec, and say like they're fine. Okay. Well, what you could do is you could take those components and you put them right back on a known working board, and does the problem go away? Is this going to just be a marginal failure where the component is just outside of the lower test spec limit, and that may be a candidate for something called tolerant stack up? Because generally, like for example, a 20% tolerance cap usually comes from the vendor with at 18% tolerance plus 2% tolerance for thermal shock. But I've noticed that sometimes the tester does not have really good contact, and sometimes you'll get erroneous readings, and that may be just a test point kind of issue when the board's hit on the better nails. And usually how that will show up, if the component is used on several locations on a panel, but you only have one reference ID that has the same defect, and it's kind of an indicator that you may have a test jig issue. Now, however, that doesn't happen all the time. You may have something very wrong with the components, but it only shows up intermittently, and so the mere act of removing it from the board can actually self-heal the component, and that may be due to damage to the foil, say like inside the capacitor, or you may have an inductor where the winding has an intermittent contact reflowing the component, or you may just have insufficient solder and you have just an open from the terminal lead to the component to the circuit board. And again, you need to have a open mind and just follow where your investigation carries you. Like for example, if you have an X-ray machine, it's very valuable for detecting internal damage to a component, such as the inductor may have a winding that's has a break inside, and that may be intermittent, and so putting it through the heat cycle will make and break the contact. Another thing that can happen is your production line could be banging the components, or not the components, but the boards together. So when they're put in the magazine rack, sometimes what will happen is, say like if this is a board, the adjacent panel could hit the either the one above it or below it and cause impact damage to the components. And usually that's easily identified by a witness mark on the outside of housing, and you could see that under magnification if you use a stereo microscope. Okay, I want to summarize what you do. First thing is you need to do material containment. And it doesn't matter if it's an internal or external event, that just sort of gives you some breathing space to allow the production line to continue moving along while you investigate the root cause. And so what you do is you interview the line tech, and you see what kind of samples that they've been using to replace components, their date code, and then you remove those from the production line in the warehouse, and you put them in the containment area. And then later on, after you test the samples, you can determine do you have an internal or external issue. If it's an internal, then you talk with your fellow production worker teams to determine the root cause. If it is a external event, then you address it with the vendor, and you'll probably need to prepare samples to send it to the vendor for their FA, and then let them do investigations so that they don't repeat this issue in the future. So again, after you've done your material containment, then you may need to notify your internal buyer and also production scheduling. Make sure that they have enough remaining material to continue production later on down the line. Okay, here's the part where you determine that is your issue an internal or external root cause. And if it is, again, if it's an internal event, have your core teams inside the loop to help you address the problem. If it's an internal problem, then you may need to communicate with the vendor to have them FA on the components. And so during this time, you may need to do some interim analysis on the suspect components by doing a disassembly or by looking for witness marks on the component where they've been physically hit. Look for anything that's out of the ordinary, using an X-ray machine, and also it's of course it's electrical characteristics of the component. Okay, later we'll on another segment go into the details on differentiating between determining if you have an internal or external issue by looking at specific examples of component defects. So I hope you enjoyed this and have a good day.